Somewhere far above the roof over your head, past the streetlights and the clouds and the thin blue edge of the sky, the universe is quietly keeping a secret it has held for billions of years. Tonight, we are going to explore a discovery that gently rearranges almost everything you were ever taught about your own home. For as long as anyone can remember, Earth has been called the perfect world, the one rare place in all that darkness where life somehow found a way to begin. But scientists searching the sky with their most patient and powerful instruments now believe they have found 24 other worlds, distant and silent, that may be even better suited for life than the earth beneath your feet. And what they began to understand out there was stranger and softer and far more humbling than anyone had dared to imagine. How can a planet possibly be more alive than the one that made us? Where in all that endless dark do these gentle worlds drift, circling stars whose names we have only just learned to whisper? And why? After so many centuries of believing we were something rare and singular and alone, are we only now beginning to learn that we may be wonderfully ordinary until you finally understand that ordinary, in a universe this vast, might be the most hopeful word of all? If you find a quiet comfort in drifting off to the strange wonders of distant worlds, you might gently tap the like button, or follow along, so that these calm journeys through the night sky can keep finding their way back to you. Now let us begin. Long before there were telescopes, long before there were cities or clocks or names for any of the lights overhead, there were people who looked up. They lay back on cooling ground at the end of a long day, the way you are lying back now, and they watched the sky fill slowly with stars. They had no idea what those stars were. They did not know that each tiny point of light was a sun, and that many of those suns held worlds of their own. They only knew that the night was vast, and that it was beautiful, and that it made them feel small in a way that was somehow comforting rather than frightening. Every human being who has ever lived has shared this one simple experience: the looking up, the wondering. It is one of the oldest things we do, and underneath the wondering, almost always, there has been a single quiet question, asked in 1,000 different languages across 1,000 generations. Are we alone? Is there anyone else out there, on some other shore of the dark, looking back toward us and asking the very same thing? For most of human history, there was no way to answer that question. The sky was a ceiling. The stars were decoration. People told stories about them, drew shapes between them, named them after animals and heroes and gods, but no one could truly reach them or know them. The lights were simply there, far away and untouchable, and the question of other worlds remained a dream, the kind of dream you have right at the edge of sleep, where anything feels possible and nothing has to be proven. And yet, even without telescopes, even without any of the tools we now take for granted, those early people learned the sky with a patience we can scarcely imagine. They watched it for so long and so faithfully that they came to know its rhythms by heart. They noticed that certain stars returned to the same place at the same time each year, and they learned to read the seasons in them, to know when the rains would come and when the cold would arrive. They built great circles of standing stone to mark the rising of the sun on the longest day. They gave the brightest stars names and stories, and passed those names down from parent to child across uncounted generations. The sky was their first calendar, their first clock, their first great book, and though they could not reach it, they belonged to it in a way that perhaps we have half forgotten, lying as we so often do beneath roofs and city lights that hide the stars away. Maybe that is part of why a night like this one feels so restful. To lie back and let the mind drift up toward the stars is to do something profoundly old, something woven into us across all those generations. You are doing tonight what your most distant ancestors did beside their fires, what countless others have done in every age and every land. You are looking up and wondering and letting the vastness hold you. It is one of the gentlest and most human things there is. But the universe, it turns out, is even larger and stranger than those early dreamers could have known. When we finally built instruments strong enough to look closely, we discovered that our own galaxy, the Milky Way, the soft band of light that arches across a truly dark sky, is not made of a few thousand stars. It is made of hundreds of billions of them, somewhere between 100 billion and 400 billion stars, all turning slowly together in one enormous spiral, like a wheel of light too big for the mind to hold. And that is only our galaxy. Beyond it lie hundreds of billions of other galaxies, each one its own vast wheel of stars. The numbers grow so large so quickly that they stop meaning anything at all. They become less like figures and more like the feeling you get standing at the edge of the ocean at night, when the water disappears into the dark and you cannot tell where the sea ends and the sky begins. That is the true scale of the place we live. That is the size of the dark that holds us. It helps, sometimes, to try to feel a number like that rather than simply hear it. Imagine you decided to count the stars in our galaxy, one every second, never stopping, never sleeping, day and night, without pause. To count just 100 billion stars, the lower end of the estimate, you would need to count without rest for thousands of years. You could begin now, and your distant descendants, thousands of years from tonight, would still be counting. And that would only carry you through a fraction of the higher estimates. And only for our single galaxy among the hundreds of billions of others. Or think of it this way. Scientists have long noted that there are likely more stars in the observable universe than there are grains of sand on every beach and in every desert on the entire earth. Every grain, on every shore, in every dune, gathered together. And still the stars outnumber them. You do not need to hold that number in your mind. You could not, and no one can. You can simply let it wash over you, like the sound of waves, vast and soft and endless, asking nothing of you at all. For a long time, even after we understood how many stars there were, we did not know whether those stars had planets. It seemed likely. It felt almost lonely to imagine otherwise. But feeling is not knowing. And science is patient. And so the question waited. Did other stars have worlds circling them, the way our sun has Earth and Mars and Jupiter circling it? Or was our solar system somehow special, a rare little arrangement of planets in an otherwise empty sky? The answer, when it finally came, did not arrive all at once. It arrived slowly, the way the warmth of a room arrives slowly when you come in from the cold. In the 1990s, for the very first time, scientists confirmed that, yes, there were planets orbiting other stars. They called these distant worlds exoplanets. An exoplanet, in the simplest words, is any world that circles a star somewhere outside our own solar system, a planet that belongs to a different sun. That first discovery cracked the sky open. Once we knew that other worlds existed at all, the only question left was how many, and the answer to that question kept growing. Year after year, larger and larger, until it became almost difficult to believe. We did not find a handful of exoplanets. We did not find a few hundred. We found thousands. And from what those thousands told us, scientists began to realize that the galaxy is not sprinkled lightly with planets. It is absolutely full of them. In fact, one of the most quietly astonishing things we have learned is this. In our galaxy, there are more planets than there are stars. Nearly every star you can see, and the countless more that you cannot, very likely holds at least one world of its own. When you multiply that out across all those hundreds of billions of suns, you arrive at a number that sounds almost like a fairy tale. There are likely trillions of planets out there, trillions of worlds turning quietly in the dark, most of which no eye has ever seen and no name has ever touched. Let that settle for a moment. Trillions of worlds. Worlds with mountains and oceans and weather. Worlds with sunrises that no one has ever watched. Worlds where, perhaps right now, a wind is moving across an empty plain, or rain is falling into a sea, with no one there to notice it at all. The universe is not a small and lonely place with one precious blue marble at its center. It is a vast and crowded garden. And we are only just beginning to learn how many flowers are blooming in the dark. And yet, here is the gentle mystery at the heart of all this. With trillions of worlds out there, we have still never found one exactly like Earth. Not one. In all that searching, across all those thousands of confirmed planets, there is no perfect twin of our home. No second Earth turning in the dark with the same blue oceans and the same soft white clouds. Our planet, for everything we have learned, still appears to be unique in the precise way it carries life. For a long time, this was the story we told ourselves. Earth was rare. Earth was perfect. Earth was the gold standard. The one world that had gotten everything exactly right. And any other planet that hoped to hold life would have to be as much like Earth as possible to have any chance at all. It was a comforting story. In its way, it made us feel special. It made us feel chosen. But science has a quiet habit of upending our most comfortable stories, and it did so here as well. Because a small number of researchers began to ask a question that, at first, sounded almost backward. What if Earth is not the best possible world for life? What if Earth is merely good enough? What if somewhere out there in all those trillions of worlds, there are planets that are not just like Earth, but actually better, wetter, warmer, older, kinder to living things in ways our own planet never managed to be? It is a strange thought to sit with. We are so used to thinking of Earth as the summit, the peak, the highest that a living world can reach. To imagine a planet more hospitable than our own feels almost like imagining a color we have never seen. And yet, the more these researchers looked at the question honestly, the more sense it made. Earth is wonderful. Earth is precious. But Earth is also, in many ways, a difficult place to be alive. Think for a moment about how much of your own planet is hostile to life. Vast deserts where almost nothing grows. Polar regions locked in ice for most of the year. Mountains too high and too cold to breathe. Deep oceans where sunlight never reaches. Earth has nurtured an astonishing abundance of living things, but it has done so on only a thin and fragile skin of habitable ground, surrounded on every side by places that would quickly kill almost anything that tried to live there. Our world is generous, but it is not gentle. It is generous in spite of being harsh. So the researchers wondered, if you could design a world to be even kinder to life than Earth, what would you change? You would not start from scratch. You would start from Earth, the one example of a living world we actually have, and you would ask very carefully which of its features hold life back and which features could be made a little more forgiving. And when you ask the question that way, slowly and honestly, the answers begin to appear, one by one, like stars coming out at dusk. This way of thinking belongs, in large part, to two researchers who put the idea into clear and careful words in the year 2014. Their names are Renee Heller and John Armstrong. They were the ones who gave this strange and beautiful notion a name. They called such a world superhabitable. Not simply habitable, like Earth, but superhabitable. A world even more welcoming to life than the one that made us. It is worth pausing on what it takes to propose an idea like that. When Heller and Armstrong first suggested that worlds might exist that are better for life than Earth, they were pushing gently against one of the deepest assumptions in all of science, and in all of human feeling, for generations. The unspoken rule had been simple. Earth is the measure of everything. If you want to find life, look for a place as much like Earth as you can. That assumption was so quiet and so total that most people never even noticed they were making it. To set that assumption down, even for a moment, takes a particular kind of patience and courage. It is the courage to look at the one home you have ever known and say, with great affection, that it is not the center of everything, that it is not perfect, that it is one good world among what may be a great many better ones. There is something humbling in that, and there is something freeing in it too. It is the same feeling, in miniature, that our ancestors must have felt when they first realized the Earth was not the center of the heavens, but one planet circling one ordinary star, Ideas like this rarely arrive to applause. More often they arrive to raised eyebrows, to polite doubt, to the quiet resistance of people who have grown comfortable seeing the world a certain way. And that, in its own slow fashion, is exactly how good science is meant to work. An idea is offered, it is questioned, it is tested against the evidence, patiently, over years. And only if it survives all of that does it begin, gradually, to be believed. Heller and Armstrong offered their idea, and then the long, quiet work of testing it began. There is a particular kind of quiet bravery in work like this, and it is worth honoring, even as you drift. Most of the great turning points in how we understand the universe did not arrive in a single dramatic flash. They arrived as small, careful suggestions, offered by people willing to be wrong, willing to be doubted, willing to spend years patiently building a case that might, in the end, come to nothing. The person who first suggested the Earth moves around the Sun, rather than the Sun around the Earth, faced a world that was certain of the opposite. The people who first imagined that the soft band of the Milky Way was made of countless individual stars had no way to prove it for generations. Every one of them had to hold a quiet conviction in the face of doubt, and wait, sometimes longer than a single human life, for the evidence to catch up. And so it has always gone. A patient mind notices something that does not quite fit. It asks a question that no one else is asking. It offers an answer, gently, knowing it may be wrong. And then it waits, while the slow machinery of discovery turns, while telescopes are built and skies are searched and numbers are gathered, one by one, across the years. To propose that Earth might not be the finest of all worlds was a small act of that same patient courage. It asked us to loosen our grip on a comforting belief and to let the universe be larger and stranger and more generous than we had assumed. That is never an easy thing to do, but it is, in its quiet way, one of the most beautiful things human beings have ever learned to do. What makes their idea so interesting is that it is not a wild guess. It is built carefully, piece by piece, from things we already understand about how life works and how planets behave. They did not simply imagine a paradise and call it superhabitable. They reasoned their way toward it, asking at every step, what would actually help life thrive, not just survive? And to follow their reasoning, we first have to understand something that sounds simple, but is in fact one of the hardest things humans have ever attempted. We have to understand how, across distances too vast to imagine, we manage to find these distant worlds at all. Because here's the thing. You might think that finding a planet is as simple as pointing a telescope at it and looking. That is how it works in our imaginations. We picture an astronomer leaning into an eyepiece and seeing a small, round world swim into view, the way you might see Saturn and its rings on a clear night. But the truth is far stranger and far more delicate than that. Almost none of these distant worlds have ever been seen directly. They are simply too far away, and too dark, and too close to the blinding glare of their own stars. Imagine standing in a dark field at night, miles away, trying to see a single moth fluttering next to a lighthouse. The lighthouse beam is so brilliant that it drowns out everything near it. The moth is there. It is real. But its faint shape is utterly lost in the flood of light pouring from the lamp beside it. That is very nearly the problem astronomers face when they try to see a planet directly. The star is the lighthouse, almost unbearably bright. The planet is the moth, small and dark, and hopelessly close to all that glare. To photograph a planet directly, the way you would photograph the moon, is called direct imaging. And it is so difficult that only a tiny handful of worlds have ever been found that way. So, if we usually cannot see these planets, how do we find them? The answer is one of the most clever and patient tricks in all of science. We do not look for the planet. We look for the gentle effect the planet has on its star. We watch the star very carefully, and we wait for it to tell us, in tiny whispers, that a world is circling there in the dark. The first of these whispers is a small and regular dimming of the star. Picture yourself sitting in a quiet room in the evening, with a single lamp glowing across from you. Now imagine that. Every so often, a tiny insect crawls slowly across the face of that lamp. For just a moment, the light grows a hair dimmer, because something has passed in front of it and blocked a sliver of its glow. Then the insect moves on, and the lamp brightens again. If you watched patiently enough, you could learn a great deal about that insect simply from how the light dimmed, how much, and how often, and for how long. This is exactly what astronomers do, on a cosmic scale. When a planet passes directly between us and its star, it blocks a tiny fraction of the star's light, and the star appears to dim ever so slightly. Then the planet moves on, and the light returns. This is called the transit method, and it is the way most of our distant worlds have been found. By measuring how deeply the star dims, scientists can estimate how large the passing planet is. By measuring how often the dimming repeats, they can learn how long a year is on that world, how quickly it circles its sun. From a few flickers of fading light, a whole planet takes shape in the mind. It is worth pausing here, because this transit method, this patient watching for the faintest dimming of a distant star, is the heart of one of the most quietly heroic stories in all of modern science. For there was once a space telescope built almost entirely for this single purpose. A telescope named Kepler. And the story of what it did is a story of patience so deep that it can soothe you simply to think of it. Kepler was launched into space and given one task. It was to stare, without blinking, at a single patch of sky. Not to sweep across the heavens, not to dart from wonder to wonder, but to hold its gaze steady on one small region, watching the same field of stars, more than 100,000 of them at once, looking for the tiny, repeated dimming that would betray a passing world. Think of the patience in that. A machine flung out into the dark whose entire purpose was to watch, and wait, and watch some more. To notice a fading of starlight so slight that it would be like seeing a single distant street lamp grow a hair dimmer as a moth crossed in front of it. and then to wait weeks or months or years for that same faint flicker to repeat, confirming that a world was truly there, circling faithfully in the dark. Kepler did this for 9 long years. 9 years of unbroken attention, of staring quietly into the same stretch of sky, gathering its slow harvest of fading light. And in those 9 years, it did something that changed forever how we understand our place in the cosmos. It identified thousands upon thousands of distant worlds. It transformed the question of other planets from a dream into a catalog, from a maybe into a multitude. And then, in the year 2018, after 9 faithful years, the little telescope finally ran out of fuel. Its work was done. It fell silent, and now it drifts quietly through space, no longer watching, its long vigil complete, like a sentry who has at last been allowed to rest. But the gift it left behind was extraordinary. When scientists went through all the data Kepler had gathered, all those years of patient observation, they arrived at a number that still astonishes. They came to believe that in our galaxy alone, there could be at least 300 million potentially habitable worlds. 300 million planets, rocky and solid like our own, sitting in that gentle ring around their stars where liquid water could exist. 300 million places where, perhaps, a sea could lie under an open sky, and that is only a careful estimate, drawn from a single patch of the heavens. The true number, across the whole galaxy, may be far larger still, from the patient watching of one quiet machine. An entire crowded galaxy of possible worlds came slowly into view. There is a second whisper, too, even more subtle than the first. A planet does not simply circle its star like a small thing orbiting a large fixed point. In truth, the planet and the star pull on each other, and so the star itself wobbles, very slightly, tugged this way and that by the gravity of the world going around it. Picture 2 dancers holding hands and spinning slowly. The larger dancer barely seems to move, but if you watch closely, you can see them sway, pulled by the weight of their partner. Stars sway like this too, just a little, and that tiny sway shifts the color of their light in ways our instruments can measure. From the rhythm of that sway, we can sense the unseen partner, the planet, swinging quietly around in the dark. And there is a third way still, stranger than the others, that uses the very fabric of space itself. Gravity, we have learned, bends light. When the gravity of a star or a planet passes in front of a more distant light source, it can act like a lens, gently magnifying and warping the light that streams past it. By watching for these brief brightenings, these fleeting moments where the cosmos itself seems to focus, astronomers can detect worlds that no other method could ever reach. It is called gravitational lensing. And it is, in a way, the universe lending us a magnifying glass made of nothing but the weight of distant things. What unites all of these methods, the dimming and the swaying and the bending of light, is how unbelievably faint and delicate the signals are. We are not talking about bold, obvious signs. We are talking about a star growing a fraction of a fraction dimmer for a few hours. About a sway so small it changes a star's light by an amount almost too tiny to measure. These are whispers, not shouts. To catch them at all takes instruments of extraordinary sensitivity, and it takes something even harder to build into a machine. It takes patience. It takes watching the same star not once, but again and again, for months and years, waiting for a faint pattern to repeat itself enough times to be sure it is real and not just noise. There is no rushing it. The planets keep their own slow time, circling once every few days or every few years, and all we can do is wait and watch and trust that if we are patient enough, the truth will slowly reveal itself. It is a kind of listening, really, a long, quiet, attentive listening to the faint music of distant suns. And there is something restful in knowing that this is how the deepest discoveries are made. Not by force, not by hurry, but by waiting gently in the dark, paying close and patient attention, until what was hidden finally shows itself. These methods do not work alone. Used together, layered one upon another, they let us find more and more worlds with each passing year. And as we found them, we began to sort them. The way you might sort shells gathered from a beach. Some of these worlds are enormous balls of gas, larger even than Jupiter, the giant of our own solar system. Others are small and rocky and solid, more like Mars, or more like Earth itself. And among all of them, scientists learn to look first for a very particular kind of world, in a very particular kind of place. That place has a lovely name. It is called the habitable zone, though many scientists prefer to call it the Goldilocks zone, after the old story of the child who wanted her porridge neither too hot nor too cold, but just right. The Goldilocks zone is the band of space around a star where the temperature is just right for liquid water to exist on the surface of a world. Too close to the star, and any water would boil away into vapor. Too far, and it would freeze into ice. But in that gentle ring in between, water can pool and flow and gather, and where there is liquid water, there is at least the possibility of life. It is worth dwelling on how narrow and how precious that gentle ring really is. Move a world a little too close to its star, and its oceans rise into the sky as steam and are lost. Let it drift a little too far, and those same oceans lock solid into endless ice. The band where water can stay liquid, where it can rain and pool and run in rivers to the sea, is a thin and forgiving margin. A slender zone of just right hung in the cold of space. Our own Earth sits comfortably within it, which is why you have known all your life the simple miracle of water that flows. You have seen rain fall and rivers run and waves break on a shore, and never once had to think of how delicately balanced it all is. how our world rides quietly in exactly the right place to keep its water soft and moving. Every glass of water you have ever drunk is a small gift of that narrow zone. And out among the stars, the search for life begins by searching for other worlds lucky enough to ride in that same gentle ring around their own suns. Water, you see, is the one ingredient that life as we understand it cannot do without. Every living thing we have ever known is built around it. So when we search for worlds that might hold life, we begin by searching for worlds where water could remain liquid. We look for planets resting in that warm and forgiving band, neither scorched nor frozen, where a slow rain could fall and an ocean could endure. But the zone alone is not enough. A world must also be the right size, neither so small that it cannot hold on to its air, nor so large that it crushes everything beneath a sky of impossible weight. And the star itself must cooperate. It must be the right kind of star. And above all, it must be steady. Here we come to something that sits at the very center of this whole story. Something so important that the researchers built their idea of superhabitable worlds around it. Not all stars are the same, and not all stars are kind. Our own star, the Sun, is what astronomers call a yellow dwarf. It is a calm and steady star, and it has been burning gently and reliably for more than 4.5 billion years, giving Earth the long, quiet stretch of time that life needed to slowly take hold and grow complex. We rarely think to be grateful for that steadiness, but it is one of the great quiet gifts of our existence. Our sun has been patient with us. It has not flared up and scorched us away. It has simply shone, year after year, age after age, holding the door of life open long enough for us to walk through. But not every star is so gentle, and to understand why some distant worlds might be even better for life than Earth, we have to understand the different kinds of suns that burn out there in the dark, and the very different stories they tell. Consider, first, the smallest and most common stars of all. They are called red dwarfs, and they are cooler and dimmer than our sun, glowing a deep and quiet red. There are vastly more of them in the galaxy than there are stars like our own. And around these red dwarfs, we have found some of the closest exoplanets to Earth. Worlds that feel almost like neighbors in the great scale of things. One of them in particular has captured the imagination of nearly everyone who has heard of it. Its name is Proxima b, and it is the closest known exoplanet to our own solar system, resting just 4.2 light-years away. That distance sounds small, but a light-year is the distance light travels in an entire year, moving faster than anything else in the universe. 4.2 light-years is still so far that if you could somehow travel there in the fastest spacecraft we have ever built, the journey would take many tens of thousands of years. And yet, in the unimaginable scale of the galaxy, Proxima b is practically next door. It is the nearest other world we know of, circling the nearest other star. Proxima b was first detected in the year 2016, found by a sensitive instrument called the Kepler Telescope, which listened for that gentle sway of the star being tugged by an unseen world. The world it found orbits a red dwarf star named Proxima Centauri, and remarkably, it sits right inside that Goldilocks zone, in the gentle ring where liquid water could exist. When it was first found, scientists thought Proxima b must be at least 1.3 times the mass of Earth, a slightly heavier cousin of our own world. But later, using an even more precise instrument named espresso, they refined that figure and discovered that Proxima b is only about 17% more massive than Earth, closer in size to our home than anyone had dared to hope. A small, rocky world, the right distance from its star, sitting quietly in the dark, possibly holding water on its surface, possibly waiting. For a little while, it seemed almost too good to be true. The nearest star to our sun had a world in its habitable zone, a world remarkably similar in size to our own. People began to dream of future spacecraft, faster than anything we have ever built, sailing across those 4.2 light-years to see what was there. Of all the trillions of worlds in the galaxy, here was one within reach of our imaginations, a destination, a possibility, a quiet hope hanging in the southern sky. But the dream came with a shadow. And that shadow reveals exactly why Heller and Armstrong began to think that worlds like ours, around stars like ours, might not be the best places for life after all. Because red dwarf stars, for all that there are so many of them, have a temper. They are prone to sudden, violent outbursts. And in that same year that Proxima b was found, the star Proxima Centauri unleashed an enormous solar flare. A burst of energy so vast that for a short time, it shone 1,000 times brighter than the entire star around it. That flare washed over Proxima b with roughly 4,000 times more ultraviolet radiation than the Earth would ever receive from a flare on our own gentle sun. Sit quietly with that for a moment. A flood of radiation 4,000 times stronger than anything our sun has ever thrown at us, pouring over that small and hopeful world. Researchers believe that an outburst like that, or many of them over the long ages, could have stripped away whatever life might have begun there, scouring the surface clean, undoing in a single violent afternoon what may have taken ages to build. The nearest world to us, the one we dreamed of reaching, may have been sterilized again and again by the very star that warms it. Its sun is not patient. Its sun is not kind. And this, in a single haunting example, is why the steadiness of a star matters as much as the warmth of it. There is something almost tender in the lesson hidden here. We so often imagine that the most important thing for life is to be in the right place, at the right distance, with the right warmth. And those things do matter, deeply. But Proxima b whispers something gentler and wiser than that. It tells us that being in the right place is not enough if the place is not safe. That warmth without steadiness can be a cruelty. That what life truly needs, more than almost anything, is to be left alone, in peace, for a very long time, so that it can do its slow and patient work undisturbed. A calm star is not a dramatic thing. It does nothing remarkable. It simply shines. quietly, without flaring, without raging, holding the door open and asking for nothing. And it may be that this quiet, unremarkable steadiness is the rarest and most precious gift a world can be given. The same, perhaps, could be said of a quiet, unremarkable night, in which nothing dramatic happens at all, and you are simply left in peace to rest. So the researchers began to think differently. If a violent star can erase life from even a perfectly placed world, then perhaps the most important thing for life is not simply being in the right zone. Perhaps the most important thing is time. Long, uninterrupted, gentle time. A star that does not flare and rage. A star that burns slowly and patiently for ages beyond counting, holding the door of life open, not for billions of years, as our sun does, but for far, far longer. And it turns out that such stars exist, and they are not even rare. They are called orange dwarfs, and to scientists they are known as K-stars. They sit quietly between our own yellow sun and the small, temperamental red dwarfs. They are cooler than our sun, a little less massive, a little less bright, glowing with a soft orange light. And here is the wonderful thing about them. There are far more of these orange dwarf stars in the galaxy than there are stars like our sun. Perhaps 50% more orange dwarfs than yellow ones scattered through the Milky Way. They are common, they are steady, and above all, they are extraordinarily long-lived. Our own sun, that steady yellow dwarf, will shine for roughly 10 billion years in total before it changes and dies. That sounds like an eternity, and in human terms, it is. But an orange dwarf star can burn gently for somewhere between 17 billion and 70 billion years. Read those numbers again, slowly, and let their weight settle over you. 70 billion years. That is many times the entire age of the universe as it now stands. A world circling such a star would have time beyond all human imagining. Time for life to begin, and fail, and begin again. Time for it to grow slow and strange and complex. Time, simply, to become whatever it might become, without the threat of its sun burning out or boiling over. It is almost impossible to truly feel a span of time like 70 billion years, and you do not need to try. But here is one small way to hold it gently. If you imagined the entire history of our Earth, all 4.5 billion years of it, every age of ice and fire, every rise and fall of mountains, every creature that ever lived, compressed into a single ordinary day, then all of recorded human history, every empire and every story ever written down, would take up only the very last fraction of a second before midnight. That is how brief we are against the age of our own world. And now, imagine a world circling a calm orange star, given not one such day, but a dozen of them or more, stretching on and on into a future so distant that our own sun will have long since faded. On a world like that, life would have time that makes the entire history of the Earth look like a single quiet morning. There is no need to grasp it. You can simply let the bigness of it loosen something in your chest, The way looking up at a clear night sky loosens something, reminding you softly that time is vast and gentle and in no hurry whatsoever. And neither tonight are you. To understand why that extra time matters so deeply, you only have to look at the story of life on Earth. Life here did not appear fully formed. It crept into being slowly, almost unbelievably slowly. It took roughly 3.5 billion years for complex life to evolve on our planet, and something closer to 4 billion years before advanced life, life capable of looking up and wondering, life like ours, finally emerged. 4 billion years of patience, 4 billion years of the sun shining steadily while, in the seas and on the shores, the work of becoming quietly went on. Now imagine a world that had not 4 billion years, but many times that. A world circling a calm orange star with tens of billions of years of gentle light still ahead of it. If life there had begun even a little earlier, or simply had more time to develop, it could have grown more complex, more abundant, more deeply rooted than anything we know. The researchers found, when they thought it through, that there is a kind of sweet spot in the age of a world, a superhabitable planet, they reasoned, would ideally be somewhere between 5 and 8 billion years old enough that life has had ample time to flourish, young enough that its star still burns with plenty of life ahead, mature, settled, and unhurried, a world in its long and patient prime. And there is one more quality the researchers imagined for such a world, perhaps the most intimate of all, because it is the very thing you are doing right now, in this moment, without thinking about it, breathing. A superhabitable world might hold more oxygen in its air than Earth does. On our own planet, the oxygen we breathe is not some lucky accident of geology. It was made slowly by life itself, breathed out across billions of years by the green and growing things of the world, until our whole sky was rich with it, a world with even more oxygen, in a thick and gentle atmosphere, could support larger and more abundant living things, more vigorous, more various, filling every niche. The air itself would be a sign of life and a gift to it. And so as you lie here, taking each slow breath, you are doing the most ancient and ordinary thing a living creature can do. The very thing that fills a living world's sky and marks it, across the light years, as alive. Each breath in, each breath out. The same simple rhythm that might, on some far world, be filling an entire sky. This is the first thing they find when they imagine a world kinder to life than our own. They find that it should be older than Earth, and circle a calmer, longer living star, so that life upon it has been given the one thing Earth's history shows it needs most of all, which is simply time. The second thing they find concerns size. Earth, for all its grandeur, is a fairly small planet, and its small size carries quiet costs. The researchers reasoned that a world somewhat larger than Earth, perhaps around twice its mass, what we call a super-Earth might actually be more welcoming to life. And the reasons, once you hear them, feel almost gentle in their logic. A larger world holds on to its inner heat for longer. Deep inside every rocky planet, including our own, there is a slow warmth produced by the natural decay of elements in the planet's heart. A heat that drives the movement of continents and the churning of the world's interior. In a larger planet, that inner warmth would last longer, keeping the world geologically alive and active for a greater span of time. A larger world also has stronger gravity, and that stronger pull would help it hold on to its atmosphere more securely, wrapping the planet in a thicker, more protective blanket of air, less likely to leak away into space over the long ages. And there is something lovely in what that thicker air would allow. On a world with a denser atmosphere, tiny living things could be carried more easily on the wind, drifting through the air to settle in new places, spreading life from shore to shore and continent to continent. The very thickness of the sky would help life travel and take root in more corners of the world. A larger planet would also simply have more room, more surface, more land, more coastlines, more sheltered valleys and warm shallows where living things could gather and grow. Where Earth offers a thin and crowded stage for life, a superhabitable world might offer a far broader one, with more space for more kinds of living things to find their place. Let yourself picture such a world, just for a moment, as you settle deeper into the quiet. Imagine standing on its shore in the soft light of its calm orange sun, a light warmer and gentler than our own, falling golden across a wide and shallow sea. The air is thick and easy to breathe, rich with oxygen, heavy with the green smell of growing things. Vast forests run down to the water, lush and dripping and ancient, full of life that has had billions of years longer than ours to spread into every corner. Warm rain drifts in from the horizon and falls without hurry. Nothing rushes here. The sun will not flare. The land is broad and the seas are wide, and there is room, endless room, for life to wander and settle and grow. It is a place we will almost certainly never visit, a place we may never even be sure is truly there. And yet it costs nothing to rest in the imagining of it, this warm and patient world, breathing slowly under its gentle sun, somewhere far out in the peaceful dark. That is the second thing they find. A world a little larger than Earth, warmer in its heart, stronger in its grip, wrapped in a thicker sky, with more room for life to spread and settle and stay. The third thing they find is warmth, though only a little of it. We tend to think of Earth's climate as ideal, and for us, of course, it is. But across the long history of our planet, life has flourished most riotously, not in cool eras, but in warm and humid ones. The researchers reasoned that a world whose average surface temperature was around 8 degrees Fahrenheit warmer than Earth's, paired with more moisture in the air and across the land, could be even more abundant with life than our own world is now. Not scorching, not unbearable, just gently warmer and wetter in a way that life tends to love. To picture such a world, you do not even have to leave Earth's own past. Long ago, in a stretch of time scientists call the early Carboniferous period, around 359 million years ago, our planet was a far warmer and wetter place than it is today. Vast portions of the land were covered in dense, dripping forests, swamps thick with green, the whole world breathing like one enormous tropical rainforest. Life was everywhere. It spilled across the land and filled the warm, shallow seas. That is roughly the climate the researchers imagine for a superhabitable world. Not a desert, not an icebox, but a warm, green, water-laden world, humming with growth in every corner, the way our own planet once hummed in its lush and ancient youth. So this is the picture that slowly assembles itself, feature by gentle feature. A superhabitable world would be older than Earth, with more time behind it and more time ahead. It would be somewhat larger, with more room and a thicker, more protective sky. It would be a little warmer and a good deal wetter, draped in tropical abundance. It would hold more oxygen, perhaps in its richer air. And above all, it would circle a calm and patient star. Very likely one of those long-living orange dwarfs. A sun that does not rage or flare, but simply shines, steadily and kindly, for tens of billions of unhurried years. When Heller and Armstrong took all of these qualities and went searching through the worlds we had already found, looking for planets that matched even some of these gentle ideals, they arrived at a list: 24 worlds, 24 distant planets and possible moons, scattered across the dark, each one carrying at least some of the qualities that might make it not just habitable, like Earth, but superhabitable, kinder to life, more welcoming, more forgiving, worlds where, if life ever began, it may have had every advantage that our own world, for all its beauty, could never quite provide. 24. It is a small number against the trillions of worlds out there, and that is part of what makes it feel so precious. These are not random planets. They were chosen with great care, selected because their stars are the right size and the right age, and burn with the right patient light, and because the worlds themselves rest in that gentle Goldilocks ring where water can flow. Many of them circle stars, much like our own steady yellow sun. Others circle those long-living orange dwarfs, with their tens of billions of years of quiet warmth still to come. Each one is a small possibility, hanging in the dark, waiting to be understood. Let us drift, gently, toward a few of them. The way you might wander slowly through a quiet garden at dusk, pausing here and there at the flowers that catch your eye. We have already met Proxima b, the closest of all, that small rocky world 4.2 light-years away, sitting in the habitable zone of its temperamental red dwarf sun. It is a reminder that nearness is not the same as kindness, that a world can be close and well-placed and still be battered by a violent star. Proxima b taught the researchers to look past mere position and to value steadiness and time above all. A little farther out lies another quiet candidate, a world named Gliese 667 CC. It rests about 23.62 light-years from Earth, and it carries at least 3.7 times the mass of our planet, making it a true super-Earth, larger and heavier than the world beneath you. But the most wonderful thing about Gliese 667 CC is its sky. It does not circle a single star, the way Earth circles its one sun. It belongs to a system of 3 stars, bound together in the dark. If you could stand on its surface and look up into its daytime sky, you would not see one sun, but a small gathering of suns, a primary star burning nearby, and 2 more distant companions hanging like bright jewels farther off. Imagine that. A warm day under 3 suns, the light layered and strange, shadows falling in more than one direction, a sky that no human has ever truly seen, but that may shine over some quiet world right now, in this very moment, while you lie here in the dark. And then there is perhaps the most poignant of them all, a world sometimes given the tender nickname Earth 2.0. Its true name is Kepler 452b, and it circles a star remarkably similar to our own sun. A calm yellow star like the one that warms us. In so many ways, it seems like a mirror of home. But there is one difference, and it is the difference that makes this world quietly haunting. Its star is about 1.5 billion years older than ours, and because of that, Kepler 452b is not so much a glimpse of another Earth as it may be a glimpse of our own Earth's distant future. Its star, having burned through more of its long life than our sun has begun to swell and brighten, expanding slowly into what is called a red giant, the great glowing phase that aging stars enter near the ends of their lives. Some who have studied it wonder whether an ancient civilization might once have risen on that world, or on a moon circling it, in the long ages before its star began to change, and whether or not anyone ever lived there. The world stands as a gentle warning and a gentle reassurance all at once. It shows us, written across the sky, the road our own planet will one day travel, billions of years from now, when our own steady sun grows old. It is a reminder that nothing is forever, not even worlds, not even stars. And it is a reminder, too, that there is no need to fear that distant ending, for it lies so unimaginably far ahead that all of human history is barely a single breath beside it. These are only 3 of the 24. There are more, each with its own quiet story, its own particular gifts, its own slim and lovely chance of holding life. Together, they form a kind of constellation of possibility, scattered across the dark, each one a place where the universe may have done what it did here on Earth, only better, only kinder, only with more time and more room and more patient light. And it is worth remembering, as we drift among them, just how astonishing it is that we can speak of them at all. A few short generations ago, not one of these worlds was known to exist. They were not on any map, not in any book, not even in anyone's dreams in their true and specific form. They were simply part of the great unknown dark. And now we can name them. We can say how far away they lie and how heavy they are, and what kind of star they circle, and how old that star may be. We have reached out across distances that light itself takes years and decades to cross. And we have learned the quiet facts of worlds we will never touch. There is something almost unbearably hopeful in that. It means the unknown is not fixed. It means the dark gives up its secrets, slowly, to those patient enough to ask. And it means that the things we do not yet understand tonight about the universe, about ourselves, about whatever troubles we carry, are not closed doors. They are simply rooms we have not yet entered. The light is coming. It always does. It only takes a little patience and a little time. But here we come to the great and humbling difficulty. We have found these worlds. We have measured their sizes and their distances and the ages of their stars. We can say, with care, that they appear to be the right kind of place, and yet we cannot, with the tools we have had until very recently, look at any of them and know for certain whether anything actually lives there. We can find the doorways. We have not yet been able to see what lies beyond them. The greatest missing piece has been the air. If a distant world holds life as we understand it, its atmosphere might carry the fingerprints of that life. Certain gases that living things produce, above all, oxygen. On Earth, the abundant oxygen in our sky is itself a product of life, breathed out over billions of years by the green and growing things of our world. To find oxygen in the air of a distant planet would be one of the most powerful hints imaginable that something there is alive. But for a long time, we had no way to sense the air of a world so far away. The worlds were simply dots, sizes and orbits, with their atmospheres locked away from us, too faint and too distant to read. That, at last, is beginning to change. And this is where the story turns gently toward hope, and toward you, and toward the world you actually live in, here and now. For we have begun to build instruments of almost unbelievable power, telescopes designed not merely to find distant worlds, but to read them. The greatest of these is a magnificent observatory called the James Webb Space Telescope, the long-awaited successor to the famous Hubble Space Telescope that served us for so many years. It was designed to do things no instrument before it had ever managed, to peer into the faint and ancient light of the universe and to study the distant worlds we have found with a clarity we had only dreamed of. The plan was to send it into space aboard a powerful rocket called the Ariane 5, and after a long history of careful preparation, it did indeed reach the sky and take up its station. But it did not stop at the edge of the atmosphere, the way many telescopes do. It traveled far beyond, out to a special and lonely point in space, roughly 940,000 miles from the Earth, well beyond even the orbit of the Moon. There, in the cold and the quiet, far from the warmth and glare of our own world, it settled into orbit around the Sun, the largest observatory humanity has ever lifted off the ground, unfolding its great golden mirror to catch the faintest light from the deepest dark. Think, for a moment, of the patience and care woven into a thing like that. A telescope so large it could not even fit inside the rocket in its finished shape, and so had to be folded up like a piece of origami, carried into space, tucked and folded, and then, far out in the dark, unfolded slowly and perfectly, petal by golden petal, a maneuver so delicate that thousands of small steps all had to work flawlessly, with no one able to reach out and fix it if anything went wrong. It took many thousands of people, across many countries, working patiently for many years, to build and fold and launch and unfold that single instrument. And all of it, every bit of that effort, was in service of one quiet purpose: to see a little farther, to gather a little more light, to answer, even partly, the oldest question we have ever asked. There is something deeply moving in that. The thought of so many hands and minds working so long and so carefully, simply to help us understand the dark a little better. We are, it turns out, a species that will fold a golden mirror and fling it 1,000,000 miles into space, just to wonder more clearly. That is a gentle and beautiful thing to be. And here is the part that touches directly on our story. Researchers have developed a new and delicate technique that may allow this telescope to detect a particular signal, a faint signature produced when oxygen molecules in a world's atmosphere collide gently with one another. If that signal were ever found in the air of a distant planet, it would mean that the world holds oxygen. And oxygen, as we have learned here on Earth, may mean life. For the first time in the long history of our looking up, we may be able to study the very breath of another world and ask whether something there is breathing too. There is a limit, of course, a gentle one. For a world circling one of those small red dwarf stars, with an atmosphere something like Earth's, the planet would need to lie within about 16 light-years of us for even this remarkable telescope to detect that whisper of oxygen. 16 light-years is a vast distance by any human measure, and yet, in the scale of the galaxy, it draws a small circle of hope around our own little corner of space, a neighborhood of nearby worlds close enough that we might one day read their air and learn their secrets. Beyond the detection of life, this great telescope was built to study the whole sweep of cosmic history, to gaze at distant exoplanets and far-flung galaxies, and even to glimpse the first faint glow of light from the dawn of the universe itself, the ancient afterglow of the very beginning of everything. It is, in a sense, a machine for remembering, for looking so far across space that it looks back across time, all the way to the early ages of the cosmos. And it is not alone. Already we are preparing its companions, instruments that will carry the search still farther. There is another great telescope on the way, named the Nancy Grace Roman Space Telescope, expected to launch in the later part of this decade. It will carry a field of view roughly 100 times wider than that of the old Hubble telescope, allowing it to survey enormous stretches of the sky at once. It was designed to probe two of the deepest and strangest mysteries in all of science: the unseen dark matter and the mysterious dark energy that together make up most of the universe and yet remain almost entirely unknown to us, felt but not seen, like a current beneath the surface of the sea. But for our story, what matters most is something else this telescope is built to do. It will be able to make direct images of distant worlds, actually capturing their faint light, something almost impossible to do from the surface of the Earth, and it will gaze deep into the crowded heart of our own Milky Way galaxy, using that gentle trick of gravitational lensing, the universe's own magnifying glass, to find perhaps thousands more distant worlds we have never seen. With each new instrument, the circle of what we can know grows wider, and the dark fills slowly with more and more discovered worlds, like a sky brightening grain by grain toward dawn. So, what does all of this mean for you, lying here in the quiet, far from any telescope or distant star? It means that you are alive at a remarkable moment, a hinge in the long human story. For thousands of generations, people looked up and asked whether we were alone, and had no way to answer. And now, for the first time in all of human history, we are building the tools that may finally let us know the question that haunted our ancestors around their ancient fires, the question whispered in every language under every sky, may at last be answered, perhaps within a single human lifetime, perhaps within yours. And whatever the answer turns out to be, there is comfort in it. If we find that we are alone, then how precious this small blue world becomes. This one warm light in all the dark, worth every ounce of our care. And if we find that we are not alone, if somewhere among those 24 gentle worlds, or among the trillions beyond them, something else is alive and breathing and perhaps even looking up and wondering, then the universe becomes a far less lonely place, a great shared house with many lit windows. And we are simply one family among many, learning slowly that we were never truly by ourselves at all. This is not a question that belongs only to scientists, locked away in observatories. It is one of the most human questions there is, and it touches everyone, whether or not they ever think about it directly. Are we alone? It sits underneath so much of what we feel. It is there in the quiet hope that we matter, that our small lives are part of something larger. It is there in the comfort we take in one another, in the way we gather close against the dark. And for the whole of human history, no one could answer it. Every person who ever wondered it had to live and die without knowing. But the children being born now may grow up in a world where the answer is finally known, one way or another. That is an extraordinary inheritance to be handing forward. And whatever the answer turns out to be, simply living at the moment when it might be found is its own quiet privilege. A front row seat to one of the oldest stories we have ever told. There is something deeply soothing, too, in the sheer scale of it. The worries that fill our days, the things we carry, the small, urgent troubles that feel so enormous in the moment, All of them grow very quiet when set against a sky of trillions of worlds and stars that burn for 70 billion years. Not meaningless, never meaningless, but held, somehow, in a much larger and gentler perspective. You are a small and living thing on a small and living world, in a universe so vast that your very smallness becomes a kind of peace. You do not have to hold everything. The cosmos has been turning patiently for billions of years, and it will keep turning while you rest. There is nothing here tonight that you need to solve. Think, for a moment, of the patience woven through this entire story. Stars that burn for tens of billions of years. Worlds that take 4 billion years to grow life capable of wondering. Telescopes that travel nearly 1 million miles into the dark just to sit still and listen. Researchers who set down the oldest assumptions of their field and waited years for the evidence to speak. Everything in this story moves slowly, gently, without hurry. The universe is in no rush. The stars are in no rush. And tonight, neither are you. You can let the day's hurry fall away and move at the pace of the stars, which is to say, hardly at all. Perhaps the most beautiful idea in all of this is the simplest one. For a long time, we believed that Earth was the best of all possible worlds. The peak, the summit, the one place that had gotten everything right. And now we are learning, gently, that this may not be so. That there may be worlds out there even kinder to life than our own. Older and warmer and wetter and more patient. Circling calm orange suns that will shine for ages beyond our reckoning. And rather than making our own world feel small, this thought makes the whole universe feel generous. It suggests that life is not a single impossible accident that happened once, against all odds, and might never happen again. It suggests that life may be something the universe does naturally, in many places, given water and warmth and time. That the great dark is not barren, but fertile, not empty, but full of quiet possibility, only waiting for someone patient enough to look. And we are looking now. After all these thousands of years of wondering, we are finally, truly looking, with eyes of glass and gold flung far out into the dark. Whatever they find, the looking itself is a kind of triumph, a quiet fulfillment of the oldest human longing, the longing to know what else is out there, and whether we are alone. And perhaps the gentlest gift in all of this is what it does to the way we hold our own small lives. It is easy, in the middle of an ordinary day, to feel that our troubles are enormous, that the things weighing on us are the very center of the world. And then you learn that there are trillions of worlds, that stars burn for tens of billions of years, that whole civilizations might rise and fade on planets we will never see, under suns that set in colors we have never imagined, and something loosens, Not because your life stops mattering, it matters as much as it ever did, but because it is suddenly held within something so vast and so old and so patient that the sharp edges of worry begin to soften. You are a living thing, briefly awake, on a small blue world, in an unthinkably enormous and beautiful cosmos. That is a strange and wonderful thing to be, and it is more than enough. There is nothing you need to add to it tonight. Nothing you need to prove. Nothing you need to fix. You are already part of the great turning of it all, simply by being here, breathing, alive, at rest. Let us gather the whole of this gentle story now and hold it loosely one last time, the way you might run your fingers once more over the pages of a book before you close it for the night. You do not need to follow it closely. You do not need to keep hold of any of it. Let the words wash over you the way the tide washes over sand, smoothing everything as it goes. This is not a story to study now. It is only a story to be carried by, like a slow current, into sleep. So let your attention soften. Let the meaning blur gently at the edges. It is enough simply to feel the shape of it once more. The long and quiet shape of a story that began with someone looking up at the stars and ends with you, here, in the dark, at peace. It begins, as so many things do, with someone looking up, with the simple ancient act of lying back beneath the stars and wondering whether anyone else is out there in the dark. For most of human history, that question had no answer. The stars were only lights. The other worlds were only dreams. Then, in the 1990s, we found the first of them, the first exoplanets, the first worlds confirmed to circle other suns. And once we knew how to look, we found them everywhere, until we understood that the galaxy holds more planets than stars, that there are likely trillions of worlds turning quietly in the dark. A patient little telescope named Kepler watched a single patch of sky for 9 long years and showed us that our galaxy alone may hold at least 300 million worlds where water could pool beneath an open sky. And yet, among all of them, never a perfect twin of Earth. For a long while, we believed Earth was the best of all worlds, the gold standard for life. But 2 researchers, Renee Heller and John Armstrong, gently asked, in the year 2014, whether some worlds might be even better. And they gave such worlds a name, superhabitable. And then they reasoned, carefully, what such a world would be. Older, with more time for life, larger, with more room and a thicker sky, a little warmer and a good deal wetter, like our own planet in its lush and ancient youth. And above all, circling a calm and patient star, very likely one of those long-living orange dwarfs that burn gently for tens of billions of years. We learned how we find these distant worlds, not by seeing them, but by watching the gentle dimming of their stars. the slow sway of a star tugged by an unseen partner, the bending of light through the lens of gravity itself. We learned of the Goldilocks zone, the gentle ring where water can flow. We learned that our own steady yellow sun has held the door of life open for more than 4.5 billion years, and that other stars are not always so kind. We met Proxima b, the closest of all, 4.2 light-years away, sitting in the habitable zone of its red dwarf sun. And we learned how that violent star may have scoured it with radiation thousands of times stronger than anything our sun has thrown at us. We met Gliese 667 cc, a heavier world beneath a sky of 3 suns. We met Kepler 452b, that gentle mirror of our own world's distant future, its aging star swelling slowly into a red giant. And we learned that 24 such worlds, in all, have been gathered into a quiet constellation of possibility. And finally, we learned that, for the first time in all of human history, we have begun to build the instruments that may let us read these worlds. The great golden telescope resting nearly 1,000,000 miles out in the dark, listening for the faint breath of oxygen in distant air, and its companions still to come, widening the circle of what we can know. We learned that we are alive at the very moment when the oldest human question may finally find its answer. That is the whole of it. And now, there is nothing left to remember. You do not need to hold any of these numbers, any of these names, any of these distant worlds. You have come a long way tonight, across light years and billions of years, through suns and seas and silent skies. And now the journey is done, and you can set all of it down. Let the names drift away. Let the numbers soften and dissolve. Let the worlds turn on without you, patiently, in the dark, the way they always have and always will. There is nothing for you to carry now. The day is finished. Whatever it held, whatever it asked of you, it is over, and it is behind you. And you do not need to think of it any longer. The work can wait. The worries can wait. Everything that felt urgent has grown quiet and small beneath this enormous, gentle sky. You are here, and you are safe, and you are warm, and that is all that you need to be. Feel how heavy your body has become, sinking softly into whatever holds you. Let your limbs grow heavy and loose, your arms, your legs, settling deeper with every breath. Let the small muscles of your face go soft, your brow smoothing, your jaw loosening, the corners of your eyes at rest. There is no expression you need to hold. There is nothing you need to watch for. You can let it all go slack and easy, and let your breath slow, all on its own, like a tide drawing gently in and easing gently out, in and out, slow and unhurried, like the patient turning of a distant world. You do not have to guide it. You only have to let it happen, the way the stars do not have to try to shine. Each breath a little slower than the last. Each breath carrying you a little deeper into the quiet. There's nothing to remember now. Let the names drift away. Proxima and Kepler and Gliese. Soft sounds now, with no weight to them at all, dissolving like mist. Let the numbers go too, the light years and the billions of years, all of them loosening and floating off into the dark, leaving nothing behind but the gentle feeling of having traveled somewhere far away and peaceful. You do not have to hold any of it. It was never yours to carry. It was only ever yours to rest in for a while. Notice how still everything has become. The room around you. The weight of your own body, heavy and warm and at ease. There is a kind of quiet that comes at the end of a long journey, when you have finally arrived somewhere safe and there is nothing left to do but lie down. That is the quiet you are settling into now. You have come a very long way tonight, across the whole vast sky, and now you are home, and you are allowed to rest. There is nowhere you need to be. There is nothing you need to do. The universe is vast and old and patient, and it is holding you the way it holds every small and living thing, gently and without asking anything in return. The stars are still burning, far away in the dark, and they will keep burning while you sleep. The distant worlds are still turning, slow and silent, and they will keep turning while you rest. You can let go of all of it now. You can simply be here, breathing, growing heavier and softer and more still. Somewhere out in that endless dark, on a warm and quiet world we may never see, a gentle rain is falling into an ancient sea, under the soft light of a patient sun that has shone for ages and will shine for ages more. No one is there to watch it. It simply falls and falls and falls in the deep and peaceful dark. And you are here, safe and warm, drifting now toward that same deep peace. There is nothing more to know tonight. There is nothing more to do. To rest now, sleep deeply, and let the gentle dark hold you until morning.